Good morning. Hello. Thank you for joining us for today's webinar, Redefining End-to-End Monitoring, the Foundation High-Performance Architecture. This is the second in a four-part series, Redefining End-to-End Monitoring. The recording of the first webinar and registrations for the next two can be found on our website by visiting our events page. My name is Gia Mangino, and I'll be your moderator for today's event. Our presenters today are Mike Margulies, SL's Vice President of Sales, and Tom Lebinsky, CEO for SL Corporation. Mike has been an enterprise software technology leader at some of the industry's leading firms, having held executive sales and marketing positions at both Oracle and VMware, and brings a wide range of practical applications, middleware, and infrastructure knowledge to the table for SL and its clients. Tom founded SL Corporation in 1983 and is the current CEO. He has been instrumental in developing SL's graphical modeling system software, SLGMS, as well as SL's flagship product line, RTView. Today's presentation will be approximately 30 minutes, with time left at the end to address questions from the audience. If you'd like to participate in this Q&A session, please enter your question into the chat panel at any time during the event and click Submit. We'll pass it over to you, Mike.
Thanks, Gia, and thanks everybody for joining. Welcome to the second in our four-part series. As Gia mentioned, we have redefined end-to-end monitoring, and now we're going through some of the core attributes of what we see as real end-to-end monitoring systems. And this one is about performance. As we discussed in the last webinar, business focus has changed. No longer are we focused solely on saving money. Now we've actually included a sort of a renewed focus on revenue or top-line growth. And when revenue is at stake, performance and scalability and high availability become paramount. If the app goes down, you lose money. If the app performance degrades, you lose money. Data sets and user populations grow and proliferate worldwide. Technology footprints expand across tiers and across vendor stacks. And as peak operating windows expand, the challenge of managing performance and availability becomes far more complex. Traditional monitoring has actually been around for a long time and is focused primarily on the silos that exist in each individual tier. So, for example, there's a bunch of folks that have been dedicated to making sure that the hosts are running optimally. A bunch of people have been focused on databases. Another bunch of people have been focused on app servers or on virtualization tiers. And traditional monitoring has not really taken into consideration the most important thing here, which is not only does the application depend on all of these things individually, it depends on how they coexist, interoperate. So what's been missing traditionally, and what we find is absolutely paramount in end-to-end monitoring, the concept of normalization of data and correlating that data across these tiers in the context of an application, prioritizing that data so you know which application is at risk if at the compute level or at the middleware level, certain metrics are indicating a degradation in health state. And what traditional monitoring systems have done is sort of a brick wall in between the applications and the silos of compute resources that support them. End-to-end monitoring tears this down and ties together the application and service level context, all of the underlying infrastructure that supports those applications. The set of requirements has evolved for real end-to-end monitoring, again, across tiers and vendors. The first of which is high-performance architecture. The architecture itself has to be able to take in real-time information, process that information, and then render that information to users in a usable way so that they can action based on all of the data that are available to them. And then that we will be covering in the subsequent two webinars we've scheduled are an integrated dynamic service model, indicated cross-correlations, and visualizations. So let's just focus on high-performance architecture for now. Things that I wanted to start with was sort of down the business case here. And we all know why applications need to perform well so that customers don't get upset, that we don't lose customers, that we're able to capture revenue, we're able to do all of this stuff. But it's more than just looking at performance statistics. It's actually looking at holistic health state of applications, performance being one of those elements, scalability being another one. Is this system able to scale? Does it jive with what my growth plans are over the next 6 to 18 months? Have I designed this correctly? And are there early indicators that scalability might be a problem if, say, in July or in December, I'm a retailer and I'm expecting a huge influx of new customers and new orders on my top-line focused systems? Are there bottlenecks, and how can I proactively address those? Or are there other areas of alignment that I need to ensure exists so that business and IT are marching forward together? These are all business case arguments, and the business at this point cares very, very deeply on whether these applications are performing well and are able to scale and stay up and running. To turn the presentation over to Tom Lubinski, our CEO and essentially Chief Architect, and explain a little bit about the Enterprise Monitor RTView architecture, and then drill down on how the performance capabilities are built into each level of our architecture. Tom?
Okay, thanks, Mike, for that introduction. The want to focus on here today is really the architecture. As Mike said, we have a couple of follow-on webinars where we'll go into more of the visualization and something that we do in the dynamic CMDB. But what we want to highlight is about this architecture that makes it for monitoring highly complex applications that have large volumes of data. I like to say that all done already, right? Everybody is collecting monitoring data. In the diagram previous to this, there was silos. You have groups, they're collecting their data, but typically they don't make that data available to the rest of the organization. So, for example, you might have an ES message server group responsible for monitoring the messaging system, and they collect their own data, but they don't generally make that data to the end users, the actual application users. So part of what we do with the EM architecture, it's designed to allow to look across the different silos and bring data together and then make it available to the application users at the top. Not just application users, the application support people and the operations people who are responsible for keeping those applications running. Architecture we'll be talking about here is designed to support that distribution of different silos to multiple parts of the organization. And that's something that's unique about the RTView product. We also have things that make it very different, and we accomplish it. So we're going to be focusing a bit on the characteristics of the data server, which is where we collect the data and import it from other monitoring. We'll talk a bit about how our metadata layer is used to utilize the data across those different silos. And then about the server layer at the top, which is where you can have many users accessing that data in a consistent fashion and do correlation across many different technologies. So I'll talk first about the data server at the bottom, the solution. We call these components our product. We refer to them as solution packages. And with that flexible architecture, where we can collect ourselves through many different methodologies. We can collect JMX data, we can tie into imaging systems, we can make SQL queries. So it does ways that you can bring data into the system. We can also bring data in from existing tools. So we have a connector to TIBCO Hall. We have a connector to Oracle Enterprise Manager. architecture that allows you to bring data in from any existing monitoring. Many times people have their own custom code that they put in place, and they're writing to a database. So you want to pull the data from the database. So you can tune it to whatever your needs are. We can all control the rate at which we bring that data in, right? We package functionality around technologies. So solution packages are and focused around certain technologies. So we might have, for example, a WebLogic package. If we want to come from WebLogic, you would install that solution package local to the WebLogic servers or somewhat near them. We have a messaging system package that collects data about your messaging system. And then those packages can be deployed in places. They can be deployed regions and different data centers and different networks. And the data are made available to the system in a unified, consistent fashion. So here is that we're not transferring data from these remote to a central architecture. We don't keep the data localized out in the location where the data is collected. With this, the transfer of large amounts of data is not a bottleneck. We don't have a bottleneck where the central system has to get data from all the remote systems before you can do any processing. Instead, the metrics are cached. The caching system that we have built into these solution packages, the metrics are cached close to the data source so that you don't lose data. Action between these collectors and the central system is broken. We still have data in the location. It's also completely HA, high availability, so you can set it up with fault-tolerant data servers so that you cannot lose data. The aspect is that processing, looking at thresholds and alerts, that's also in those distributed servers. So do the rules processing close to where the data are being collected, which again, we don't have to wait data to be transferred centrally before we can process. It means faster response times and faster generation of alert contents. So why is caching capability? We mentioned caching. Out in those remote codes, we use a caching mechanism, which is RTView. It's designed, it's a general purpose object cache. Instead, it's a time series data cache, optimized for fast data capture, fast data retrieval, and to maintain it in a time series fashion. It's a system mechanism that maps data out to a relational database or to a NoSQL database as well. Data, in other words, we keep raw data for some defined amount of time. Then we to bucket it into intervals. So you can bucket your data into 1 minute or 5 minute or 15-minute buckets. And then that aged data that's written out to the database. What that does is it allows us to control the granularity and want to write out to your database. It's you can store all your raw data if you want, or you store aged data. This is implemented using a caching mechanism that we have inside of RTView. That are out as servers normalize and provide access in a standardized fashion to all the data that we're collecting. And we maintain at the level above a cache map that identifies where all the data are located in each servers. Doesn't matter whether it's geographically dispersed, however. And architecture supports advanced indexing, in that you can query from any one of those remote systems any set of data easily, whether or historical. It's optimized for multidimensional queries. So access just all data about one server or a group of servers, and we will return that from the remote server on demand. And this index map, where we're located, so that we, at the higher levels, do correlation. We can very quickly identify 27 metrics to this application, and 5 of them are in Japan, 6 of them are in England, and the remainder are in New York. And make a query, which brings them all back in, and I can see all those metrics in parallel with one another. Indexing mechanism. The ways that we get performance in this system is that all of the alert logic is distributed. So if thousands of servers or hundreds of individual topics, perhaps, out in a messaging system, and I apply an alert against a threshold, an alert on any of those topics or queues that might be going above a certain threshold. I don't want to transmit all that data centrally and then perform the calculations. I want to perform those alert calculations in the remote location, and that's what we do. And then what happens is we get back to the central only result of the rules processing, data that are requested on demand from the central systems. And this mechanism allows us for tracking the data that went across to different data servers. We have API provides access to any of the data located in any data server. So you have your own mechanisms for visualization. If you have a group of people who do their own BI, your own tools, you can simply access our REST API. You can query the current data. You can query the historical data. And one of the most powerful features of this REST API is that it's seamless access to the current, the short-term in-memory cached history data, as well as seamlessly making a query to the archive database so that you can simply specify a time range, and it doesn't matter whether the data are looking in memory or whether they're in the database. We return it in one function, and that REST API can, if you don't want your time worrying about where the data are located. Now, induction RTView in most cases around an agentless type of access data. Most data that you're interested in can be by some kind of agentless mechanism. Either make a query to pull the data from your apps. You can make you can do a messaging system to pull metrics about that system. You can make administer to a server to pull the data. What we try to do is to provide mechanisms that are easy to install, easy to maintain, and don't produce additional insertion of code or app. We don't use the need to start and stop and put our code on your system. Typically, we simply reference the system that you have out there. And so basically, this results in what can be low cost and low overhead architecture, specifically designed around monitoring low latency applications. Now, the system is, of course, this metadata layer. Metadata layer is what provides a cache map telling us where all the data are located in this distributed architecture, either composite or complex rules aggregated across all those. So what we do is you have 20 remote RTViewers out there. We can get across those 20 servers the result of the rules processing, as well as dynamically query any data that you're interested in. Basically partitioning the data so that we keep it local to the source and we provide data access. Where we do the visualization, there's a characteristics here. Now, this dynamic service model, we're going to do our next webinar about the service. Sometimes people refer to that as CMDB, a configuration management database. Creating a service model for your application has challenges, keeping it maintained. We've a number of techniques that use the metadata, definition of the data servers, to construct, where applicable, a dynamic service model, meaning that a server gets added to the system, that's reflected in the service that represents your application. This allows us then to identify quickly what applications are affected by probably component out there. The meta allows us to create adequately visualizations and displays that correlate across key metrics that are coded in different locations. There are ways to do role-based selection of only the data that are relevant to your application. In this display server mechanism, we provide a high-performance UI based around HTML5. One of the key find is charts. People have a lot of trend charts. And when you're looking at large volumes of data, the trend processing has to be optimized. We've developed a number of techniques here that keep the transfer down. Basically, what we do is we transfer historical data to our display when the display is first loaded, and then update it. And on the client side, continually moving trend by populating updated current data instead of transferring the whole trend chart on the update cycle. Gives very fast, high-performance visualizations. At this point, I'm going to turn it back over to Mike to talk a bit more about requirements.
And thanks, everybody. As Tom mentioned, the architecture is designed from the ground up to provide the ability to monitor in real time all of your low latency application statistics. So really at the base of this requirement set is this high performance architecture. It's designed to be cache-based and distributed rather than centralized to avoid bottlenecks. It separates the application of business logic and rules from the actual data collection and retrieval itself. So just like in a traditional n-tiered architecture, the RTView architecture allows specialization of workload, minimizes contention and latency. And lastly, we have some facilities in the UI that enable visualization in real time of very fine-grained performance statistics. So the application can both keep up, or rather the RTView monitoring system can keep up with your application at the collection and retrieval end, but also in the visualization end. The other two important requirements to keep in mind, and like we mentioned before, we're going to be covering later in our webinar series, is the use of integrating a service model for application context. Looking at technology for technology's own sake only goes so far. Without application context and without the ability to prioritize on the business criticality or severity, the business criticality of the app or the severity of the problem, there's no way to wade through this sea of alerts that you're getting. So service model context is critical. And then lastly, the ability to logically cross-correlate across these tiers so that you can see what's happening at the network and host level and how that relates to what's happening in, let's say, your coherence cache or at your EMS server level. And not a performance degradation as displayed in some of the queuing statistics is in any way related to and triaged based upon what's happening at the host or the Java server or the virtualization layer. So we'll get to that in the coming weeks. But for now, we wanted to make sure that everybody understood what the underlying architectural benefits were and how those translate into high-performance applications, make sure that they're up and running, making sure that their performance is optimized, making sure that they're able to scale. As you can see in this slide, we have many, many customers, the majority of whom who have been with us for a long time. And the reason that they continue to be satisfied by RTView is that not only do we continue to innovate and give them more of the actual intelligence about monitoring that they require and can't get elsewhere, but we have built into our product this bulletproof architecture that's designed specifically for high-performance applications that are very complex and difficult to monitor. And you'll see these customers in retail, especially with large line presences. You'll see them in banking. You'll see them in utilities. You'll see them in telco. You'll see them in logistics. All of these companies have very, very stringent high-performance requirements, and they depend on RTView to provide them with visibility into that performance health state in an easy-to-use, easy-to-implement, low-cost infrastructure. So that's what we provide. Our next webinar is scheduled for Tuesday, August 25th, so a couple of weeks out, when we're going to go into the service model integration piece. You can also get more information on our website. You can request a demo, or you can request an evaluation copy of your own and work with our technical team to evaluate the software. Watch any number of videos or download a white paper. There's a lot of information there for your review, and we're always available to answer any questions that you might have or dialogue with you and your teams. At this point, I'd like to turn it back over to Gia to solicit questions from the audience. I know we have a few, and I'll just let her drive the Q&A portion of the presentation. Thanks very much.
Great. Very much, Mike and Tom. Just a quick note, the webinar is actually on Tuesday, August 26th.
Oh, sorry about that.
That's okay. No problem at all. Just pointing out. I'd like to invite the audience at this time to submit any additional questions by entering them into the chat panel and click Submit. If we're not able to get to all of your questions during this live event, we'll be sure to follow up on any unanswered questions via email. Now let's get started because we do have quite a few. Our first question is, what are some real-world examples of how a high-performance architecture has made a difference to your customers?
I'll take that one. Tom here.
Yeah.
So I mentioned when the end of the part of the presentation there that we have that we use to optimize the visualization. So the trend charts, for example, and we have some complicated trends and with multiple that are data from multiple sources. And the customer recently where that something 3.5 megabytes of data that they display in these trend charts, using the techniques that we have for historical and updating trends using the current data to update the trend. They ended up transmitting, instead of 3.5 megabytes every couple of seconds, they were transmitting something like 15K. Or much better performance in the UI and response time and so on. An example, I mean, there's many on that theme, but we do see that kind of dramatic difference between more traditional architectures and the way we do things in RTView.
If I could add to that, the real issue is being able to capture data at the level of granularity that's material for the application properly. So if you're only able to take statistics every 5 seconds or every 10 seconds, but you really need single-second statistics, our system is designed to capture and collect and make available that data at that level of granularity. In fact, at a granularity that's completely user configurable. So there's a large number of examples where our customers are doing that in the banking industry, in the logistics industry, and in the retail industry.
Great, thanks very much. Our next question, what is the highest data rates you are able to achieve in RTView, specifically for collection, rules processing, and display?
That's a question with a lot of different dimensions to it, but I'll just, Mike, a little bit on it there, in mentioning single-second updates. I mean, indications, seeing your trends and your data update a second is pretty good. RTView has the ability to update things at a much faster rate. You can even update down to the, millisecond rate if you wanted to. Now, in practice, in real application monitoring systems, typically those are not required. They want to update and execute your thresholds at a rate of 1 every second. but you don't even want to collect the data in systems. When you're collecting data, you are always going to have some overhead involved in doing it. Try to minimize that. But many traditional monitoring systems collect at 5-minute intervals. If you go to Oracle Enterprise Manager, for example, you're lucky if you can get 5-minute data. In some ways, you can get 1-minute data. But typically with RTView, we will see users setting their collection rates more like 10, 15 seconds, and balance between minimizing any overhead of collection, really a very low minimum, and yet being able to see a sense of some behavior in the system. If you can see going on within 10 or 15 seconds, that's good. Some particular financial applications, they do like to see their data on a more like a 1 or 2 second interval, and also network management type applications. It really is in that 1 second range. Collection and visualization. And it was capable of that and actually quite a bit more.
Thank you. We have a few more questions and a little bit more time. How much customization am I able to do with RTView? Can I make flow diagrams?
Well, visualization, we didn't talk much about the flexibility of the RTView system, but there are, we've been doing this a very long time, and we have many components to our product. We highlighted today the high-performance architecture for collecting and distributing and performing analysis on large volumes of data. The vision component, which is something we will talk about in one of the webinars, is very, very flexible. Now, we have many techniques that allow us to auto-generate display to minimize the burden of the user. Users don't always want to go in and create views. Now, the question probably is to the desire that we see often for people to see their in some kind of a diagrammatic fashion. Now, there's a very powerful capability of RTView. We have a component of the product called the Builder. It's a display builder. In Display Builder, you can drag and drop components, attach those components. I mean, take trend charts and gauges and labels, things like that. Connect those components to live data. As you're building the display, see it driven by live data. And our users do construct diagrams. You can almost think of it like Visio diagrams come alive with live data, and to see their applications in that fashion, driven by data. And so the Builder does provide very sophisticated ways to do that.
Thank you, Tom, and thank you everyone for your great questions. Unfortunately, it looks like we are out of time. Just a reminder, this webcast has been recorded, and I'll be emailing a link to the recording within the next few days. Thank you everyone for joining us, and have a great day.
Thanks, everybody.